Hey everyone, and welcome to today's tutorial. We are going to be working on part 3 of our 4-part lesson on word problems when dealing with systems of equations. The theme for today's lesson is going to be mixtures and solutions. Okay, mixtures and solutions is what we are working on. So let's jump into our first example here. Regular brand coffee sells for $18 a kilogram. And premium coffee sells for $24 a kilogram. What quantity of each should be used to produce 40 kilograms of a blend to sell for $22.50 per kilogram? So we have two different kinds of coffee at each their own rate, and we are going to be mixing together, which will give us a total of 40 kilograms. And once the mixture is combined, it will be sold for $22.50 a kilogram. So what we're going to do here is we're going to make a chart to help organize some of our thoughts and the information that has been provided. Okay, so I'm looking at right across the top here, I've got 4 columns and 4 rows. Our middle 2 columns here are going to be the two different things that we are combining. So in this case, we are talking about combining regular coffee and premium coffee, so that's what I'm going to just put in here. I have regular coffee, and I have premium coffee. Off to the side here, I have my 2 pieces of information that has been given as I wrote over here. We have 2 pieces of information. We have the total amount of coffee that is to be created, which is 40 kilograms. So we know that there has to be some kind of amount for the 2 of them. I'm just going to write amount here, and I'm going to keep my units there just to be organized. The other piece of information that we know is that it needs to end up being $22.50 per kilogram, and so I can fill this in. We know that the cost is the other factor at play here. My right-hand column here, as I've written, this is the final mix. So this is going to be the blend of our 2 different types of coffee, or this is whatever the final result is going to be. Okay, we know that we are looking for 40 kilograms. And we know that we are looking at a total cost of $22.50. So that is the final mix for those 2 different factors. We know that the cost for the regular coffee is $18 a kilogram. And we know the cost for the premium coffee is $24 a kilogram. We don't know how much of each we're putting in. That's what the big question is. So I'm going to just say R is going to stand for how much regular, and P is going to stand for how much premium. Okay? Our very first equation here is going to be the amount equation that we are looking at. And the amount equation is the one that is going across the top here. I know that R plus P has to equal 40. Okay, that's just, we know that the amount of regular coffee plus the amount of premium coffee is equal to the amount in total, which is 40 kilograms. We're going to then create our second equation here by multiplying vertically within our table. So I'm going to say R times 18 gives me 18R. P times 24 is 24P. We also need to multiply vertically here. So I'm saying $18 times the amount of regular coffee times $24 or plus $24 times the amount of premium coffee is going to tell me how much in total I have. We know that this is the unit rate, and we know that we have 40 units of the coffee. We have 40 kilograms, so I need to know how much in total a package of 40 kilograms of coffee is going to sell for. So I'm going to do 40 times 22.5, which gives me 900. Okay, so a 40 kilogram bag of this blended coffee is $900, and there's some amount of either regular and premium in there. And so now we can go ahead and we can have our second equation down at the bottom here. So our second equation is the cost equation. It's the second factor that we have. We're going to do 18R 4p is equal to 900. Two variables, two equations. We now have a full system of equations, and so we can go ahead and solve. You can solve by however way you would prefer. Remember, we have substitution and we have elimination as options. I'm going to choose substitution because our first equation here, both of the variables have a coefficient of 1, and so isolating one of them is going to be very easy to do. And we can just then substitute that information in. So let's do that. I'm going to just move up here. Perfect. Okay, so our first equation, I'm just going to go ahead and isolate r. Just rewriting it. So r plus p, no, is 40, not 400, is 40. That means that r must be equal to 40 minus p. And then in my second equation here, 18r plus 24p is equal to 900. Okay, I can then substitute 40 minus p in for r. Now we're going to use distributive property to get rid of our brackets here. So I'm going to go 18 times 40 is equal to 720. 18 times negative p is negative 18p, plus 24p is equal to 900. Okay, I'm going to move my 720 over to the other side so I can collect my like terms here. Negative 18p plus 24p gives me 6p. 900 minus 720 is equal to 180. I divide both sides by 6 to get that p is equal to 30. Okay, P was our premium coffee. Remember, P was the premium coffee. So now we know that there are 30 kilograms of premium coffee in this mixture. I can then go through and I can substitute that P is equal to 30 back into my first equation in order to solve for R. To get that R is equal to 10. Let's just draw some arrows here. Okay, we now have the two different values of R, and we have P, and so I can write my therefore sentence. Therefore, there are 10 kilograms of regular coffee and 30 kilograms of premium. In this blend. Okay, so pretty straightforward. Getting the hang of using the table is going to be the trickiest part here, just because it's a new way of organizing your thinking. If you're the type of person who is able to jump from the word problem, the information, and you can jump straight to the equations here without using the table, by all means, you can go ahead and do that. You don't need to use the table. It is just useful for many students. Okay, so there's our last solution. Okay, let's take a look at our second example here, our second and final example. A vinegar water solution is needed to wash windows. The cleaner needs to make 1,200 liters of a 28% solution. He has a 16% solution and a 36% solution. How many liters of each must be mixed to make the 28% solution? I'm just going to go through my problem here and highlight some key information. We know that our total amount here is 1,200 liters, and we know that it needs to be at 28%. We have a 16%. We also have a 36%. So let's go ahead and let's set up our table here. So just like we had before, okay? There are two key factors that we are looking at here. We are looking at the total volume, the total quantity. So I'm just gonna write volume here in liters. If you wanna write amount or just quantity, whatever makes sense for you, you can go ahead and do that. And we are also considering the percentage of the solution. Okay, that's just how strong a solution is. We have two types of solutions here. We have a weaker one and we have a stronger one. So I'm just gonna write weak. That's the one that's at 16%. And we have a strong one at 36%. And we have our final blend here. Once we have our table set up, we have. So my total volume that we were looking at is 1,200 liters. And the total percent that we are looking for is 28%. I know that the weak solution is at 16 and the strong solution is at 36%. Once again, we don't know how much of each we are looking for, and so I'm going to set some variables. Okay, now I didn't do this in the previous question, but I'm going to do it here. I'm going to use my let statement, so I'm going to say let W represent the total volume of the weaker solution. That's the 16% one. And I'm going to let S represent the total volume of the stronger solution. That one is at the 36%. Okay. We can go ahead and we can find our equations now. So our first one was where we had W and S. That was our first. So we know that W plus S is 1,200. And then remember we had to multiply down. So we had to say W times 16 is 16W. S times 36 is 36S. And then we have to do 1,200 times 28 gives us 33,600. A question that I can imagine you might be asking is, do I have to do whole numbers here because percents are technically decimals? Absolutely, you can treat all of this as if it is a decimal. You can write 0.16, 0.36, and 0.28. Either or, it's just as long as they remain consistent, that's the biggest key here, okay? Our second equation across the bottom of our table, okay? That is 16W plus 36S is 33,600. Once again, I would suggest using substitution in this example, only because we both of our variables in our first equation have a coefficient of 1, and so they're very easy to isolate. Just for the sake of it, I'm going to use elimination here, just as a reminder and a refresher for the different types of solving systems of equations. What I'm going to do is I'm going to multiply my entire equation here by 16, and then that way the coefficients on my W's are going to match up, and I can go ahead and way. So this will give me 16W plus 16S is equal to 1,200 times 16 is equal to 19,200. We remember to draw our subtraction line and indicate that we are subtracting here. 16 minus 16W, those just cancel out. 36S minus 16S is 20S. 33,600 minus 19,200 gives us 14,400. I then now divide both sides by 20 to solve for S. S is equal to 720. Remember, 720 is the volume of my stronger solution, so I know that I have 720 liters of the stronger solution. We can then use that information to find my weaker solution. By substituting S in for, or 720 in for S in my first equation, I then rearrange to isolate. 1200 minus 720 is equal to 480. So I have my two pieces of information there. Okay, that's what we were looking for. I can then conclude with a therefore statement. I can say therefore the 1200 liter solution has 480 liters of 16% mix and 720 liters of 36% mix. Okay, and that's how you end it off there. Once again, if you don't feel the need to make that table, you by all means can just jump straight to the equations. You just want to make sure that all of your pieces of information are staying straight and organized in front of you. And that's it. Thanks for listening, folks.